Okay, yesterday was law of cosines, and we have set this one up, just a little review problem on law of cosines. We got it changed to a c here because m wasn't a good variable because it's not in our formula. Here's our formula, and notice it's only got a's, b's, and c's. And there is a big C, that's the angle. I needed an angle right here, so we called this one c so that we would have an angle for c, so I can put that all in the formula. Now, if I pick a to be that, then that means little a is 12. So 12 squared plus 10 squared minus 2 times 12 times 10 cosine of 40 is equal to c squared. Those are all just numbers. And you multiply them and add them and subtract them, etc., and you get this big number, and a lot of times people write down that and say that's their answer. It's too big of a number, though. What are you supposed to do at the end? Square root. What was the number before you took the square root? 60 what? 60.15? Good enough. Okay. Then, if you just think about it, look at that. How can that be 60? You know what I mean? That's just not possible. So, you take the square root of that, and what did you get? Can anybody verify 7.8 approximately? All right. All right, cool. We figured out that third side. Now, could we go on and figure out an angle? Yeah. But remember what I said about law of cosines yesterday? You can use it again, but this is not so easy. So what should you use instead? Law of sines. Because now you have an angle and a side across from it, and that's better for law of sines. Okay. All right. So then, what is next? Well, we already did a ambiguous case where you have something like this. This is 8. Nope, sorry, that one's unknown. If this was 8 and this was some unknown distance, like let's say, let's make it 7, then it could go here or it could go there. I'm just doing a quick reminder that the ambiguous case kind of question is all about using law of sines, and you find an angle, and don't get confused, you're not finding this angle, you're finding that angle. And once you get that one, it's the same as that one. These two are equal. That's the key to that ambiguous case kind of question. All right, next, let's talk about the lab. We're going to go out and get data today so that you can do the height of the commons lab. All right, and the first way I want you to do it is the super simple way. There is a spot in the commons where you can measure bricks or tiles, and they're about 1 foot on each side, so it's pretty nice. You can just trust that each, I know it's off slightly, but if you really think about it, everything we're going to be doing, all the measurements are going to be off a little bit, and it's okay. So you're going to count the tiles, and you're going to be able to count all the way up to a spot directly underneath a spot on the ceiling. Okay. And let's say this ends up being 27 feet. And then you're going to use your cell phone and get an angle. It goes all the way up to that spot on the ceiling. I kind of missed. I'm going to try that again. I'm going to actually go down. There. And let's say this ends up being 44 degrees. Do you get how that should be fantastically easy to figure out h, the height? Okay. So what do you need for that? Well, you need to be able to handle putting up your cell phone on its side, being in a measure app, and it tells you how many degrees. If you're doing it right, 0 degrees is what it should say when you're holding it exactly level. When you're looking across that, here's your eyeball, and you're looking down here. Of course, you should be looking at the horizontal at that point and not at the ceiling. And then you tilt it up, and now your phone will be tilted like this, and your eyeball, will be looking down here at the spot on the ceiling. Okay? And it'll say, like, 44 degrees or whatever on the side of your phone. One thing, when you start tilting it up super high, you'll notice that it gets weird when all of a sudden you're looking almost straight up with your phone. It'll all of a sudden switch back to like 15 degrees. What in the heck is happening? Because this is not a 15-degree angle. Think about what the cell phone designer did there. That all of a sudden makes it, when it gets to be a big degree, it switches to a small degree. You know what's going on? Yeah, it's this angle. They're saying that angle's 15 degrees. Could you still figure out this angle? Yeah, it would just be, what would you do? 90 minus that. Does that make sense? So don't let your partner tell you, if you're tilted and looking like almost straight up, then they say it's like 5 degrees. It's not 5 degrees. What is it actually then? Like 85 degrees. Okay, so don't get fooled by that. It usually only happens on angles that get bigger than like 50 or 60 degrees, then all of a sudden it might switch over. And so you could be like 60, 65, and then all of a sudden it says like 15. What? It's because it's switching to measuring from the vertical. Okay, so some of you, the vast majority of you, have already got your app on your phone, Measure app. I don't need everybody to have that. I just need one person in each partner group. Unfortunately, the app, or the I was going to say the iPads, they have the Measure app, but they can't do the angle thing on the side. You can't switch it to level, it's called. So I would recommend that you just use a phone, and if you or your partner, either one of you, have a phone with a level app, then ask me. You can borrow my phone. All right? So one last thing. I want you to this is the easy way to do it. What is the hard way? You are going to imagine for a moment this is a spot that is on the ceiling. You want to make that spot as close to the edge where the wall meets the ceiling as you can. Like, you don't want to pick a spot right in the middle of the commons. You want to have a spot that's over near where the wall meets the ceiling. Okay? Then you are going to be standing on the floor and go, let's say, at a complete right angle. So now I'm going to change it to, this is an overview of the commons, and here's those round tables and stuff. So I'll show you the spot out in the commons where you can go stand right here and sight to a spot on the ceiling, and then go at a 90-degree angle to that and walk at least 10 blocks, 10 tiles over, which would be 10 feet. At least 10. Actually, the more the better. And then redo an angle from here. Again, these are difficult to draw for you, but you're sighting back to the same spot here. And I'm going to try to give you my best 3D impression of this. And you might want to copy this for your lab to try to, I wouldn't just do it exactly the way I do it, but I'm going to say, imagine that this is the spot where you are taking the angle. And that's you, where this is you, and you are sighting this angle, and it's going to be like around 40 degrees-ish. Okay? And this would be where the wall would be, and that's where the ceiling is up there. Then you're going to go at a right angle to that. Do you get that these two are supposed to be making a right angle to each other? And you're going to go about 10 feet over. And then you're going to be sighting from here up to the ceiling. And this angle should be smaller. The first time you do it, you are straight on to it. As in, you're here, you're looking up at a spot that's dead ahead of you. You're at a 90-degree angle to the far wall. And then you are going to walk over, 10 feet over, and you'll do it again. Of course, that makes a right triangle on the ground, but I'm trying to make you see how there's a right triangle right there, and the green one to the black one is also a right angle. All right, so I think I've explained it as much as I can, and until you get actually out there and see, I'll show you out there in the commons where to take some measurements. And then the easy way, you should be able to find the height of the commons before you walk out of the commons. You should be able to be done with that and say, oh, it looks like it's about 60 feet or whatever. Okay, you'll figure it out. Then the hard way is this way with the 90-degree angle. That's the one that's going to be a lot more work, and that's why this lab isn't due until Monday. So you have plenty of time, including the weekend, to work on it. And you have a partner who you can consult and see, like, am I doing it the same way you're doing it? Okay? All right. So before I end the video for today, I'm going to show you where the homework is. So I'm going to pause for a second. Okay, it's got today's date on it. Actually, hold that thought a second. Pausing. Okay, the title within Schoology is 2-12 on the assignment because today's date is February 12th. Okay, so anyway, arrow down to near the end, and you got this page. There's two problems. You're going to use law of cosines, of course. And then you've got this page and this page. And that's it. That's your homework for tonight. And brownies have arrived, so I'm done. That's all I got for you for today.